Okie dokie. Hey guys, how are you doing? Welcome back to the 10th tutorial for GCSE Mathematics. This is the 10th. Thank you guys very much for joining me. Apologies that I wasn't able to attend on Friday. I wasn't feeling too great, but no corona, we're all good. We're back today. And we are going to be doing quadratic sequences today, okay? So hopefully we can just get this sort of wrapped up in half an hour, such that everybody understands it. We've got Stuart in the chat who's going to be more than willing and happy to help you guys out. So guys, please contribute, please ask questions, and yeah, just always try to keep it as interactive as possible. Yeah, so without further ado, let's just go ahead and get straight into the live. Let's go. All right, so I like to start off always with a question. So let's have a go at this question. All right, so determine the second difference of the following sequences: 5, 20, 45, and 80. Thanks, David. It's nice to see you guys on. Hey, Ella, Natalie, Marcus, Din, Kaz, great to see you guys. Great to see you guys. Let's see if you can find the second difference of this current sequence we've got here, this sequence. Who's got it? Who's first in? The second difference. There's a bit of a lag, mind you, so it takes me maybe longer than normal to feed in. So we've got 10 coming in from Din. We've got 10 coming in from Ella first, actually, and then David. Anybody else? Who's got the second difference of this sequence? Okay. Okay. It's time to reveal the answer. Okay, okay, Marcus, what does the second difference mean? Well, we'll go through that just now. Okay, so the first difference is the difference you get by taking the difference of the original sequence. Okay, so between 5 and 20 is a difference of 15. The difference of 45 and 20 is equal to 25, and the difference of 45 and 80 is 35, right? So that would be the first difference, okay? The second difference is simply the difference between these values, okay? So the difference between 25 and 15 is 10, and 35 and 25 is also 10, okay? So the number I was looking for was 10, okay? Hopefully that makes more sense to you, Marcus. And well done, everyone, for those of you guys who got that right. Fantastic stuff. All right, on to the next. All right, determine the second difference of the following sequence. Okay, Marcus, hopefully you can try and contribute to this one now. Have a go. What's the second difference of this sequence? All right, so we got -2 from Ella. Anyone else? Ella's first in again. Start developing a nickname for Ella. Fast Finger Ella. Fast Finger Ella. Kind of, that's a good. Oh, Marcus. Marcus comes through with -2 as well. Okay, Joanne Kanu. Hey, Joanne. Nice to see you. Haven't seen you on before. Thank you for contributing -2. Natalie as well. Kaz -2. All right, let's go through this. Okay, so the first difference between the terms of the original sequence are -4, -6, and -8. And the second difference between these terms here are -2. Okay, so the second difference is indeed -2. Fantastic, guys, and well done, Marcus, for picking that up so quickly and delivering a correct answer. Smashing stuff. All right, let's go for the next one. Ooh, algebra. Okay, so we've got these terms here, and I'd like you to calculate the second difference. Okay, the second difference. Who has got this? Who's going to get this one first? Don't be intimidated by algebraic terms, okay? The rules always stay the same, okay? The method still applies, okay? All right, so we've got 6A coming in from Natalie, 9A coming in from Ella, okay? David comes in with 6A. Anyone want to change their answer? Or you strongly believe it's whatever you think it is? Anyone else out there? Couple of us viewing. Let's see you guys contributed. So Ella changes it to 6A, no problem. Joanne as well, 6A, fantastic. Okay, so let's go through this. As I said, the same rule applies. Okay, we need to find out the first difference. Okay, the first difference is calculated by taking the difference between consecutive terms of the original sequence. So taking the difference between 12A plus 1 and 3A plus 1. Well, 12A minus 3A is equal to 9A, and 1 minus 1 is equal to just 0. So you're just collecting like terms and evaluating between consecutive terms, and that gives us as a first difference of 9A for the first term of the first difference, 15A and 21A. So you guys should check these. 48 minus 27 is equal to 21. So that gives us 21A. And so the second difference is indeed going to be 6A. That's the difference between 15A and 9A. And it's also the same difference between 21A and 15A. Okay? Good stuff. Nice to see you on, Mohammed. All right, let's try the last one. Slightly harder. You just got to think about it a little bit more. Try things out, maybe. Yeah, well done, Natalie, on that. Good. Who's gonna be able to calculate the first difference and then use that to calculate the second difference? Anybody? Few more seconds. Anyone coming through with an answer? Okay, so we got -4 in from Natalie. -4 in from Ella. Okay, Marcus as well. All right, good stuff. -4 from Kaz. Well, we'll find out. All right, so let's have a look at this question. All right, so the stage, what we've been doing before is we've been calculating the first difference, but in this case we have a ... here, which doesn't make the first difference so clear. However, if we take the difference between consecutive terms, which we can see that we have -14 and -18. Okay, now if we assume that the second difference is constant, it's just an assumption at this stage. Notice that there are 4 units between the second difference, the first difference rather. Okay, so then that implies that there should be 4 units between other differences. Okay, so assuming that the difference between assuming that the other term is going to be -10 and -6, because there are 4 units between the terms, that lands us, if we subtract -10 from a value to give us -13, that value must be -3, okay? And if we do the same thing for 3, it gives us if we do the same thing for -6, which is 4 units between -6 and -10, that gives us 3 here, okay? So that actually works. Using this first difference works for us, okay? And notice that there are 4 units between each of these terms, giving us a second difference of -4, okay? So good stuff, guys. A little bit of trial and error and a bit of assumption there, but what we did was we used the fact that we assumed that the second difference was going to be constant. We found out the difference between terms in the first difference, a lot of words differences being said here, but hopefully you can catch on with me. And then we just carried on those same 4 units in between these terms, okay? So hopefully that makes sense. Good stuff. Fantastic. All right. So what you should notice in common between all of these sequences is that the second difference is constant, okay? It doesn't change. Whereas in the first difference, we see the values change, okay? Now, there's a special name for this type of sequence, and it's called a quadratic sequence, okay? So these are all quadratic sequence purely because the terms of the second difference are constant, as you can see here. 6a, minus 4, minus 4, minus 4, minus 2, and 10 and 10. Okay, so this is a typical quadratic sequence. All right, so let's move on. All right, so given the nth term of a quadratic sequence, the nth term which we defined in the previous live is simply just a special formula which tells you the value of a term in your sequence at a particular position n. Okay, we can given this formula we can actually write out terms. Okay, so all we do to find out terms is we substitute the values of the positions. So for example, the first term is going to be where n is equal to 1. All right, so we simply just put n is equal to 1 into the formula, and that gives us a value of 12. Okay, that gives us 5 times by 1 squared, which is just 5, plus 3 times by 1, which is just 3, plus 4, which is 5 plus 3 plus 4 is equal to 12. Okay, and we can do that to find out the next two terms by simply plugging in n is equal to 2 and n is equal to 3. Okay, giving us the second term is 30 and that the third term is equal to 48. Okay, so if you're asked, given a formula, given the nth term, to find out the first three terms, this is how you would do it. You would say n is equal to 1, n is equal to 2, and then n is equal to 3. And you smash it into the formula and it'd give you an answer of 12, 30, and 48. Okay? Now, if we were to continue writing terms, say we were to write out the fourth and fifth term, we would get 96 and 144. Okay, now some of us might be wondering, well, why are these called quadratics? Well, some of us might easily be able to see that the formula which actually defines this sequence is a quadratic one, isn't it? Okay, as the highest power, the degree is equal to 2. Okay, the highest power is a square term. Okay, however, graphically, you can also illustrate that this is a quadratic sequence. Now, if we were to plot points of position versus value, where n is the position, we would see that the plots, or the points that we plot, it actually models the shape of a parabola, okay, which is a quadratic, which is exactly how a graph would look if you were to draw a quadratic graph, okay. All right, so let's have you guys try some now. Hopefully you guys understood that. Let's have a go at this question, okay? So find the first three terms of the following quadratic sequences defined by an is equal to 2n squared plus 4n minus 3. Have a go. Okay, so I'm seeing, I think in the next couple of terms, I'm just looking at back and I believe it is 58 and not 48. Apologies, that was a slight error on my part. These things are unpredictable, especially when you're doing lives. Thank you very much for that, Ella. Good correction. And obviously, I put that mistake in there by accident to see who would notice it. All right. Okay, so we've got Ella coming in with 3, 13, and 27. 3, 13, and 27. Anyone else? Who's got the first three terms of this quadratic sequence? 3, 13, and 27. Good. All right, fantastic. Okay, so we get the first term by plugging in n is equal to 1. That's why it's called the first term. Okay, so when we plug in n is equal to 1, we get 2 times by 1 all squared plus 4 times by 1 minus 3. Evaluating this expression, we get 2 plus 4 minus 3, which is equal to 3. And to get the next two terms, we plug in n is equal to 2 and n is equal to 3, giving us a value of 13 and a value of 27. So Ella first in on that. Ella is completely on job today, literally. Good stuff, and well done, guys, for getting that right. Anyone else want to get involved, feel free to. Hopefully you got this one. Let's see if you guys can get the next one. And just to say, the answer that you would give in the exam is 3, 13, and 27. Good stuff. All right, next on, let's try this one. So an is equal to half multiplied by n squared plus 3 over 2n plus 1. Who can beat Ella? Oops, maybe not. She comes in first. She's all right. 3, 6, 10. Good stuff. All right. Oh God, you can hear my sip of tea. It's very much needed on a Monday morning, especially when you've had a late night. Anyone else? Natalie, 3, 6, 10. Anybody else? Din comes in with 3, 6, 10. It's time to go through the answers. Okay, so the first term, we can find out the first term by simply plugging in n is equal to 1. Plugging in n is equal to 1, we get half times by 1 squared, which is just 1, so we get this half here. And then we're going to get 3 over 2 times by 1 plus 1. That would give us an answer of 3, okay, for the first term. To do the rest, we simply plug in n is equal to 2 and then n is equal to 3. And this is what we get. We get half multiplied by 2 squared plus 3 over 2 multiplied by 2 plus 1, giving us 2 plus 3 plus 1 is equal to 6. You can use a calculator, or just as a bit of work for with fractions. In this case, we won't get fractions because 2 squared is equal to 4. 4 divided by 2 is equal to 2, which gives us 2 here. And the 2's cancel here, giving us 3. But do practice with your fractions. Definitely do have a go with that. And when we plug in n is equal to 3, we get a value of 10. Okay, so our terms will be 3, 6, and 10. Okay, fantastic. All right, good stuff, guys. It looks like again Ella was in there first. Natalie, Din, Kaz, good stuff. So for the guys that are contributing, fantastic. I'm very happy that you guys are doing a great job making sure you're right. Noticing that the same names are popping up all the time. Feel free to have a go if you're a new person trying it on. You'll only know if you're right if you give it a go, and you only get better if you just give it a go, and we'll help you to get to the next level. Okay. All right. So let's look at now nth terms. Okay. So finding the nth term of a quadratic sequence. All right. So we can find the nth term of a quadratic sequence using a special method. Okay. This is the general formula for the nth term, as you would have seen before. Okay. It's got a squared term, and it's of the form an squared plus bn plus c, where a, b, and c are constant terms. And these terms are unique. A, B, and C are unique to different types of quadratic sequences. Okay, so in order to find the nth term, we need to find out these terms A, B, and C for a unique quadratic sequence. Now, the method we're going to use is we're going to use a system of simultaneous equations to find out these constants. Okay, now you can even memorize it once I show you the simultaneous equations, or you can derive it. I'm going to quickly show you how to derive here because it's important to understand things. All right, so assuming that this is indeed the correct formula for a quadratic sequence, that means that we can actually write out the terms of a quadratic sequence algebraically. Okay, so for example, if n is equal to 1, if we plugged in n is equal to 1 into this formula, we get a plus b plus c. Okay, 1 squared is just 1, and 1 times b is just b. That gives us a plus b plus c. We can then write the next term by plugging in n is equal to 2. Okay, and that's going to give us 4a plus 2b plus c. Okay, when n is equal to 2, we get 2 squared, which is where we get the 4 times by a. And when n is equal to 2 here, we get 2b plus c. Okay, and doing the same thing, we can also get the third term. Okay, so what we've done is we've just found an algebraic way to write out terms of a quadratic sequence, the original sequence. And we can also do the same thing for the difference. Now, how would you normally calculate the difference? You would subtract this term here from this term. Okay, so we can calculate the first term of the first difference by doing 4a plus 2b plus c minus a plus b plus c. Okay, so 4a minus a is equal to 3a, and 2b minus b is equal to b, and c minus c is equal to 0. Okay, we can then do that for the second term of the first difference by just taking the difference between these two terms. Okay, so you can check in your own time that gives us 5a plus b. All right, So lastly, we can also do the same thing for the first term of the second difference, okay? 5a plus 3a, sorry, 5a minus 3a is equal to 2a, and b minus b is equal to 0. Okay, now what's the significance of this? Well, we now have a general expression for the first term of the original sequence, the first term of the first difference, and the first term of the second difference. Okay, and using this, we can equate this to the first term of any quadratic sequence to find out these constant terms A, B, and C. So let's have a go. All right, so let me just show you how to do the first one. So here's a sequence: 3, 7, 15, and 27. The first difference is 4, 8, and 12, okay, which we all hopefully know how to do now. The second difference is 4 and 4, okay. So as the second difference is constant, it tells us that this is a quadratic sequence. Now, what we can do using this general expression, we can equate it to the first term of each respective sequence, okay. So this is where we get a plus b plus c is equal to 3, 3a plus b is equal to 4, and 2a is equal to 4. Okay, so now we have this system of simultaneous equations which we can solve. How do we know we can solve it? Well, we've got 3 equations and we've got 3 unknowns, a, b, and c. So it means it's solvable. Okay, so from equation 3 rather, we can clearly see that a would be equal to 2, right? If we divide 2 by both sides. Now subbing a is equal to 2 into equation 2 rather, we get 3 times by 2 plus b is equal to 4. That gives us 6 plus b is equal to 4. And subtracting 6 from both sides, we get b is equal to negative 2. So we now have a is equal to 2 and b is equal to negative 2. Subbing both of those into equation 1, we get 2 plus negative 2 plus c is equal to 3. And therefore c is equal to 3. 2 minus 2 is equal to 0, and therefore c is equal to 3. Okay, so now we have the coefficients, the constant terms, which would go into this general formula, and that gives us an nth term of 2n squared minus 2n plus 3, where a is equal to 2, b is equal to negative 2, and c is equal to 3. So that's how you would find the nth term of a quadratic sequence using this particular method, okay? Now, as I said, you can derive it, but it's often quicker to just memorize it. It will not be given in your exams, okay? So you just really want to memorize that a plus b plus c is equal to the first term, and 3a plus b is equal to the first term of the first difference, and 2a is equal to the first term of the second difference, okay? So hopefully we all got that, guys. Let's have a go at this question. All right, so find the nth term of the following sequences: 4, 10, 20, and 34. We've got 2 examples. This is penultimate question. Yeah, so the formulas that Stuart's going to give you are going to be useful for finding the nth term. So a plus b plus c is the first term of the original sequence. That would mean in this case that a plus b plus c is equal to 4. Okay. Yep, and 3a plus b is equal to the first term of the first difference. And 2a is equal to the first term of the second difference. Okay, good stuff. Fantastic. We're getting responses now. All right, so we've got Ella coming in with 2n squared plus 2. Same as Natalie. So Hawk comes in with 4, 2 minus 2. Would that be the A, B, and C constants you're looking to get, Sahawk? Yeah, and you can always check your formula works. That's a great point, actually. We'll just discuss that for the first formula. Anyone else? Does anyone else have any suggestions on the nth term of this quadratic sequence? Okay, so you're on your mobile phone. Yeah, if you just tell us what A is equal to, B is equal to, and C is equal to, that would be a lot clearer to be able to see. Okay, all right, so let's go through this question. And let's just go through it. All right, so the first difference in this sequence is 6, 10, and 14. The second difference is 4 and 4, okay? And as it's constant, it means that this is a quadratic sequence, all right? And therefore, we can find out the nth term by setting a plus b plus c equal to the first term of the original sequence, which is equal to 4. 3a plus b equal to the first term of the first difference, which is equal to 6. And 2a equal to the first term of the second difference, which is equal to 4, okay? So now we have a system of simultaneous equations which we can solve because we've got 3 unknowns and 3 equations, okay? So from equation 3, you can see that a is equal to 2 by dividing 2 by both sides, substituting a equal to 2 into equation 2, we get that b is equal to 0, okay? And substituting a and b, the newfound values, into the equation 1, we get that c is equal to 2, and therefore our nth term is equal to 2n squared plus 2. All right, so we see some guys coming in with that, just as I was explaining it. Well done, Kaz, and well done, Din. Great stuff. Fantastic. Ella for coming through first. On fire. Natalie, on fire, as always. Great stuff. Let's go to the next question, okay? There was a point that Stuart made earlier. You can always check your answers, okay? That's the great thing about these nth terms. Because as I said, this is a special formula which tells us the value of terms in our original sequence at a particular position n, okay, where n is a positive integer, okay? So what you want to do to check is just check. We know that the third term should be equal to 20, so plug in n is equal to 3 and check that it equals 20. Same way if you plugged in n is equal to 4, for example, you should get 34, okay? So check that in your own time. Let's go to the last question of the day. Let's see who can get this one right first. Let's go. Okay, find out the nth term of this sequence. Take your time. Slow and steady wins the race. Okay, let's all have you guys contributing. All right, so Ella, n squared plus 7n plus 5. Okie schmokies. Ella, so Natalie comes in first with that. Ooh, just straight after Ella Greensmith with n squared plus 7n plus 5 as well. Anybody else? Anybody else? Who's got this? Who's got this? Hopefully you can use this if you're not quite clear on how to do this question. Use this, okay? Use this to help you. Use the method. Okay, Din, n squared plus 7n plus 5. Good to see. It just feels like, we're all calculating these things independently. Kaz again, the usuals. Oh, great stuff. Marcus coming through with n squared plus 7n plus 5 as well. Okay, all right, let's go through the final answer or the final question of the day. All right, so before approaching it in this way where we're going to use a system of simultaneous equations, you always need to check what type of sequence it is, okay? So the first check I'm always making is the first difference is 10, 12, and 14, and the second difference is 2 and 2. So it's constant. So now we can say it's a quadratic sequence, therefore we can approach it using these methods. Okay, so that means that a plus b plus c is going to be equal to the first term of the original sequence. 3a plus b is going to be equal to the first term of the first difference. And 2a is going to be equal to the first term of the second difference. Okay, it's a very, very wordy thing to explain, but just hopefully you can see it, you can digest it, and things will be a lot easier for you to do going forward. Okay, so now let's just solve this equation. Okay, so from equation 3, we can see that a is equal to 2 if we divide 2 by both sides. Substituting that value into equation 2, we get a value of b to be 7. Okay, so we now have a is equal to 1 and b is equal to 7. Okay, so substituting these values into equation 1, we can find out the final unknown, which is c, which is c is equal to 5. Okay, so a is equal to 1 and b is equal to 7 plus c. That gives us c is equal to 5. And finally, now we have a, b, and c. We can simply write out that the nth term is going to be n squared plus 7n plus 5. Okay, so that's how you find it. Okay, so great stuff, guys. I'm going to pop back on now, and yeah. Okay, good stuff. Well done, guys, for participating. Hopefully that was enough for you to understand what quadratic sequences are. They are mainly included in sort of, yeah, I'd say higher level GCSE mathematics. Okay, but again, I genuinely see these things as, you know, give it a try, even if you're doing foundation level. Just give it a try and see how it works. There's so many things that are, you know, you can achieve if you just, you know, you focus, you try as hard as possible, and you practice. Okay, so that's the lesson for today. On Wednesday we have Stuart back on. He's going to be doing something very different. Okay, so I definitely tune in for that. He'll be back on for the A-level guys. He's going to be doing a quiz. Okay, so it's going to be very interactive and it's going to be very competitive. Make sure you pop along. He's got something great prepared for you guys. I might be back on Thursday. Might do some mechanics A-levels. Okay, so great stuff. Thank you very much, Stuart, for joining me and helping me on the chat. We'll see you guys again on Wednesday. So pop along, and yeah, if you enjoyed the video today, just drop it a like. I'd really appreciate that. And tell your friends about it, share it with people, and also subscribe if you haven't subscribed yet. Good stuff, and I will see you guys on Wednesday. Take care, guys. Bye-bye.